Howdy, AP PreCAL, it's Miss Kosh. I am finishing up the FRQ practice set that I begged, borrowed, and stole. Well, no, I borrowed this part. I may have copied and pasted this straight from Mr. Passwater because it seems like good instructions and I didn't need to type it again. But then I created my own stuff underneath it. So we're doing FRQ 4. We think it'll model something like this. And if you look in the description of the video, I intend to put a link there to this PDF. So it's one PDF for all 4 problems, but there's 4 videos. Watch them all, like, subscribe, comment, share this with your friends, all the things. Okay, so this first one, they're giving us 2 functions, and then they tell us, so here's space for A. They're telling us solve g of x equals 2 for values of x in the domain. So my g of x, I might write it this way, is equal to log base 4 of x plus 5. And they said that this is equal to 2. Okay, so we would do, in my classroom, we would do I heart logs. So we'd say 4, so maybe not, don't write this, but here's what I'm talking about. See, it looks like a nice little, that's a terrible heart, but that's what we're going for. I have 4 squared is equal to x plus 5. So 4 to the second is equal to that. 16 is equal to x plus 5, subtract 5, x equals 11. And that is a value in the domain because I can't, the domain of this guy is going to be, well, one way to think about it is a log function typically has an asymptote at x equals 0. So if I had, here's a little side note. If my graph was y is equal to log of x, my domain goes from 0 to infinity, my range is all real. Okay, if then I take this graph and even if I change this base value, it doesn't really matter. It affects how steep it grows, or how steep it is and how fast it grows and all that kind of stuff, but it does not affect its domain and range. So this one, we've taken the graph and we've shifted it to the, what would that be, left? Okay, so this is from -5 to infinity, and this range is from still all reals. So what were we looking at here? 11 is in this domain, so life is good. Okay, back to the problem. Solve h of x equals 1 for all values in that interval from 0 to 2 pi. Okay, so this h of x is equal to 2 cosine squared x, which is, they're telling us, is equal to 1. Okay, so what would I do on this one? I would come along and say, okay, well, this is cosine squared x, it would be equal to 1/2. I can do the chair, square root, plus minus. Okay, and so I end up with cosine of x is equal to plus or minus, the square root of 1 is 1, the square root of 2, so I have 1 over root 2, but I can multiply by a funky form of 1, and I get the cosine of x is equal to plus or minus root 2 over 2, which tells me this is the pi over 4 family. And cosine, so what I'm looking at, cosine is positive root 2 over 2 at pi over 4 and 7 pi over 4, and it's negative root 2 over 2 at 3 pi over 4 and 5 pi over 4. So how did they ask for the answer? They said solve for values of x in the interval from 0 to 2 pi. So they want 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I will write it this way. I will be glad that I know my unit circle as well as I do, and I will move on with my life. That was fun. I mean, actually, I kind of enjoyed that page. My favorite so far. Okay, continuing on. The functions j and k are given here. Rewrite j as a single natural logarithm without negative exponents in any part of the expression. The result must be in the form, should be in the form natural log expression. Okay, so what are they giving us? They're telling us that j of x is equal to the natural log of x plus 3 minus 2 natural log of x minus 3 natural log of x minus 2. Oh, sorry, I think I did write this problem. Okay, so here's what I would probably do to start with. I would take this and factor out a negative. Because this whole thing can get squished together, and then it's all going to become the denominator. So it's a little harder to see. Anyway, you don't have to do this, but I think it will be helpful. Okay, so it's the natural log of x plus 3. I'm showing every possible step. This becomes the natural log of x squared plus the natural log of x minus 2. That's getting cubed. Since these are addition can get squished together with multiplication, subtraction can get squished together with division, and I'm running out of space, so it's the natural log of x plus 3 over x squared times x minus 2 cubed. Okay. And then they say rewrite k of x as an expression which cosine appears once and no other trig functions are involved. Okie dokie. So here is our k of x is equal to sine squared x over 1 minus cosine. Okay, I did write this problem, so that helps me know what I was intending. But we see the Pythagorean identity all over the place. Hopefully, my little darlings, it did enough trig identities that you are really good at this, and you know that this sine squared is equal to 1 minus cosine squared over 1 minus cosine. Well, what should I do next? Well, it starts with an F and ends in actor. I should factor. That's funny, you guys. Did you laugh? Okay. Well, marginally funny. It's over 1 minus cosine of x. This whole thing right here can cancel with that. When you divide this by this, you get 1. And so the final answer, k of x, would be equal to 1 plus cosine of x. Okay, did that answer the question? Rewrite in which cosine appears once. Okay, and no other trig functions are involved. It doesn't say only cosine. I mean, there is a 1, but it's not a trig function. This has been my favorite so far. Okay, the next one, but I love trig. The function m is given by this. Find all output values in the domain of m that yield find all input values that give us an output of 0. Okay, set this thing equal to 0. So I'm going to say m of x is equal to cosine. Can you see everything? I think you can. Cosine of 2x plus cosine of x, and we're setting this equal to 0. This is our double angle identity, and it's got 3 options, if you remember. Cosine of 2x, one of them was cosine squared minus sine squared, and then you can use the big daddy, you can use the Pythagorean identity to manipulate this. And so cosine can become 1 minus sine, and if there's a 1 minus sine squared, not 1 minus sine, 1 minus sine squared, and then another, there's 2 of them. I can also manipulate this so that it becomes 2 cosine squared x minus 1. Go back and watch my previous videos if you're like, what the heck just happened? But here's what I noticed. In this one, we're going to have to get we want everybody in terms of cosine of x, because I have a cosine x here. And so we're going to pick the option that just has cosine. So I can rewrite this as 2 cosine squared x minus 1 plus cosine of x equals 0. I could do a u substitution if you want to. Here's what I'm talking about. I could say let u, not me, but let u equal cosine x. I'm so funny, you guys. This becomes 2u squared plus u minus 1 equals 0. I switched places at the same time. And then I can factor to 2u, and there's a 1, and then there's a u, and there's a 1. And I need to figure out signs. This guy has to be positive, and this one has to be negative. So this is the positive, this is the negative. And so I end up getting u is equal to 1/2, or u is equal to -1. Not me, but you. And so this would be like saying cosine of x equals 1/2, or cosine x equals -1. Let's come back here for just a second. I could just come in and show how to factor this without doing the u substitution. And this is 2 cosine x, and then I'm going to have a 1, and then I'm going to have a cosine x and a 1, because the only way to get 2 cosine squared is to have 2 cosine times cosine. And the only way to get 1 is to have a 1 times a 1, but this one needs to be the positive one, and this one needs to be the negative one. And so this tells us that cosine x right here would equal a positive 1/2, and that cosine x is equal to -1, which you may recall is exactly what we said a second ago with the u substitution. Good math to a good answer. If that's what you like, go for it. Okay, so now we have to think unit circle. When is cosine equal to 1/2? Cosine is the x value. This is going to be at 1 pi over 3 and at 5 pi over 3. When is cosine equal to -1? It's still the x value. This is equal to pi. Let's see, did we answer the question they asked? Find all input values in the domain. Oh, no, we did not find all of them. Okay, so it's these, but anything coterminal to that. So ultimately what we need to do is we need to say x equals pi over 3 plus 2 pi k. X equals 5 pi over 3 plus 2 pi k. And x equals pi plus 2 pi k, where k is an element of the integers, is how I would write this. So this is what I would expect my kids to write. To be honest with you, I don't remember if this was more of what AP would say, and this is Miss Kosh's way of asking the question because I like all of these. I don't remember. So anyway, be prepared. I haven't seen AP use this notation. K is an element of the integers, but surely the graders know that that's what that means. I would be shocked if they didn't. But maybe if you have extra time, write out the phrase where K is an element, or K is an integer, or something like that. Yeah, I think we're done. So hopefully that was helpful. Subscribe, come back, share this with your friends. Let me know how I can help you. Go study, go practice. The only way to learn math is to do it. Goodbye.